In this video, we'll review some of the other setup options in SkyTrack. I'm assuming you already set up your site. If you haven't set up your site, refer to the video called Basic Setup, which covers that. So there's other options here under Setup. We'll go to General Setup. The first item that you can set is your definition of acquisition and loss of signal. So by default, it uses the viewing limits that you may have set up in your site. So these are, in each of these cardinal directions, the minimum angle that you can view from your particular site. So you might have a larger value in one of these if you've got a tree or a building obstructing your view. So normally you'd want this on viewing limits, but you can set it to 0 degrees elevation. And if we do that, and just do a recalc here. If the lines are in green, that means they've achieved AOS. So you can see now that we have objects that are fairly low up, flagging green, and saying they've reached acquisition of signal. If I go back and change that to viewing limits and recalculate, and we can see now, I think I have my viewing limits at 15 degrees, so until something hits 15 degrees, it's not going to come into AOS. We also have the option of ignoring the eclipse status in the past calculations. So if I click ignore and recalculate some of these, you can see here it's eclipsed, but it's going to show up. This entire pass is eclipsed, but it shows up as a pass here on October 9th at 4:54. And if I unclick that, recalculate, you can see we don't have that pass anymore. So normally with visual viewing of satellites, you wouldn't want this checked because you only want to see passes in which the object is sunlit, because you're not going to see it if it's eclipsed by the shadow of the Earth. However, if you're using SkyTrack to move a radio antenna, if you're listening to radio transmissions from satellites, then you don't really care whether the satellite is in the sun or not. So you're going to probably want to click that to get those passes. We have the option of automatically connecting your ASCOM mount on startup. So if I click that and restart SkyTrack, you'll see it automatically connects to the mount right on startup. This is the timeout, so if your mount was turned off, how long SkyTrack is going to try to connect to it before it gives an error message. Confirm before parking, so if you want a confirmation so you don't accidentally park your telescope. When I hit park, it'll ask me, do I want to park, yes or no? Otherwise, it'll just go ahead and park. You can enable slew limits. So if you're Alt-As, you can set an upper limit on altitude. So I can say don't slew any higher than 81 degrees altitude. Or I can choose declination if I'm polar mounted or equator mount. So when I do a go-to an object or during satellite tracking, if it's going to tell the mount the slew higher than this, it's going to stop satellite tracking, or it's going to pop up and it'll say that it can't go to the object because it's too high according to this limit here. So that's useful depending on your optical train. If you have a camera sticking out the back that could hit the pier if you point too high, then you might want to use this limits. These two options allow you to reverse the manual slew keys. So if you watch in the status up here right now, when I hit the left key, it says slewing west. If I reverse it, hit the left key, now it's slewing east. And the same with north and south if I want to reverse those keys. These are definitions for darkness. So it's defining astronomical darkness when the sun is minus 18 degrees elevation, and optimum darkness when an illuminated moon is less than 3 degrees, negative 3 degrees elevation. You can change those parameters if you want. The moon, you might want to change that if you think it's fine if the moon's at maybe 0 degrees elevation. And where that is important is in this tab here. There's a function here to find your next dark period. So you're looking for when's the next good time to do astrophotography, and I say, you know what, I want at least 4 hours of optimum darkness. When is that going to happen next? Click that, and it tells us that on October 29th, I'm going to have at least 4 hours of good darkness. So again, it's judging darkness by these values here, which you can adjust if you want. These are default number of days that it's going to calculate for these two things. So the first one is satellite future passes. So in this window here, it just by default sets this 7 days apart, but we can override it and go for a shorter time period. Oh, not that short. A shorter time period if we wish. So that's only going to calculate for a day now. And same with transits. The other value and setup there was what the default, just for convenience, how many days you're going to search for a transit. And again, we can override that, make that shorter if we want. Reset column width. So in all the different lists, if you want, you might want to adjust columns for whatever reason. And if you've messed around with that and you just want to reset them back, you just hit that. And now they're reset back to the default. Deep sky favorites, reset the default. What that is, you'll see anything with an asterisk beside the name is considered a favorite. And SkyTrack comes with some common photography objects set up as favorites, and they'll always be first in the list. So you can see I'm alphabetical right now with everything with an asterisk in front of it. And as I scroll down here, then I start with objects that aren't considered a favorite. So if I decided Cat's Eye Nebula, I want that as a favorite, then I highlight it, click that, and now when I go up here, I can see Cat's Eye Nebula is in here. Again, if you've messed around with that and you want to reset it back to the default to SkyTrack, you can just hit that. And then when I come back here, Cat's Eye Nebula isn't there anymore. It'll be down, listed after the favorites. Dark mode, there's on, off, or auto. There's two different themes for dark mode, a red and a gray. On auto, what it does for whatever site you've got selected, once the sun is down, dark mode will automatically come on. Once at sunrise, or the sun is above the horizon, then it'll go back to your normal colors with dark mode off. Tracking adjustment increments, so there's two different axes, your timing and your perpendicular axis, fine and coarse control. So for instance, I can set the fine to 0.25 seconds and the coarse to 2 seconds. So when I'm on the satellite, tracking a satellite, and I want to adjust My fine now is 0.25 seconds here, and if I hit the coarse, then it jumps ahead 2 seconds. So you can adjust those increments according to probably what magnification you're using on your telescope. So if you're going high magnification, you probably want to set this finer because it makes quite a difference at high magnifications. So the timing axis is in terms of seconds. The perpendicular numbers are in terms of arc minutes. Logging, normally you could keep logging on. If you want to troubleshoot something, then SkyTrack creates a log under this name. The log file won't get huge because each time you start up SkyTrack, it overwrites the previous log, so it's not gonna take up a lot of your hard drive space. You may want to turn this off. I found it's helpful to turn off if I'm capturing video to the same hard drive. So you want to give all your hard drive resource to your capturing video, and if you don't really need logging, then you can turn it off, and SkyTrack isn't going to be using any hard drive resource. The last item here is enabling Planetarium Sync in Nina, and it's a set port number. So if I go here and let's say I select Wizard Nebula, so here's a Wizard Nebula and its coordinates, and then if I go into Nina and see in framing here, this little icon here is the get coordinates from Planetarium. So if I click that, it'll get the name of the object and the coordinates from SkyTrack. And also in the sequencer, I add a new target and click the same icon. I'll get the wizard and the coordinates. So go back here and let's say change this to Swan Nebula. So there's my information for Swan. Come back here and it automatically grabs that information from SkyTrack. So that's pretty handy to set up a target in Nina. You do have to set up your Planetarium software under Options and Equipment, and there is no SkyTrack option, so I'm just using the same port number as what Cart to Seal would use. So you want to set this to Cart to Seal. If you're actually using Cart to Seal, then you'll have to turn off that with SkyTrack. So that's general setup. The next setup is ASCOM continuous interface setup. The first parameter is your tracking rate update frequency. So right now, every 1500 milliseconds, SkyTrack will ask the mount for its current position, calculate the current position of the satellite and the current rate of movement of the satellite, and then it'll update the mount variable tracking rates for each axis accordingly. 1500 is a good place to start. If you find your system is bogging down, or if the mount is bogging down, if it's too frequent, you can set it to a higher number. Or if you want to experiment with a lower number to see if you can get smoother tracking, you can do that too. But 1500 I find works pretty good. Telescope field of view. So this is a parameter you can input for your current setup. So based on your focal length and the camera or eyepiece that you're using, put in your field of view. And where this is used is on this screen. So this red circle here signifies where the mount is looking. When that red circle turns green, it means that your object is in the field of view. So if we select the satellite here and start tracking to it, and as it gets closer, as soon as that red circle goes green, it should be in the field of view. Right there. The other place it uses that information is this value down here, which is the separation between the satellite and the mark and the mount in terms of arc seconds. And you can see that's red right there. And this graph, this progress bar is red. And as soon as it gets in the field of view, both these are going to turn green. So that's just a visual signal that your object should be in your field of view now. And again, it uses this value here that you've entered when it makes that determination. This option here allows us to delay a meridian flip when we're using an equatorial mount. And often when the satellite is near the meridian, its range is closest to the viewer. This is especially important with a larger object like International Space Station. So it's gonna appear bigger the closer it is to you, and that usually happens at or near the meridian. So if you're doing video or imaging, you may want to delay the meridian flip because that's the sweet spot to do imaging. You have to make sure your mount and your setup is capable of that. You want to prevent any collisions with your peer by going too far past the meridian before doing that meridian flip. So use this very cautiously. The other thing to remember is that SkyTrack only looks at the meridian flip distance and makes a decision whether it wants to flip or not once every tracking rate update. So in this particular setup, once every 1500 milliseconds, it's going to evaluate how close am I to the meridian, do I have to do a flip. So you want to keep that in mind when you're selecting a value. So if you know you can go 10 degrees past, but only 10 degrees, you might want to set that back a little bit because it's only going to check every 1500 milliseconds whether it needs to flip or not. When you first connected to your mount, and if you chose continuous tracking, SkyTrack will prompt you to do a ASCOM tracking calibration. And if you didn't do it at that time, you can come here to do it. And it just goes into this routine. And again, that is just checking the ASCOM driver when you do a move axis command with, let's say, a positive rate, which way is it actually going to slew? Unfortunately, different authors of ASCOM drivers interpret that differently sometimes, so it'll actually move it in a different direction, and that's going to be really important to know which way it's going to move. So that's all that calibration does. SkyTrack also has legacy interface. So a legacy interface is an interface that does not use an ASCOM driver, and SkyTrack is sending the proprietary mount commands directly to the mount. In some cases, that'll result in better tracking than trying to use ASCOM. So for a few of those interfaces, there are a couple options. So astro-physics, you can change your maximum slew rate. You might want to decrease your maximum slew rate to decrease the settle time when you reach your object, or if you just want quieter slewing. Astrophysics has two different sync modes, recal or just a regular sync. And this is important in this screen here because after you go to an object, you can sync your mount to that object. And also the same type of calibration as in the ASCOM calibration, just determining which way the mount actually, which direction the mount actually goes on a move axis command. Same as the ASCOM continuous interface setup, we can delay the meridian flip, and the legacy interface for astrophysics, the frequency update is defaulted to 1.5. You can't change that. So again, you want to take that into account when you're setting this, knowing that it's only going to check to see where we are in terms of the meridian every 1.5 seconds. So you want to give yourself a little bit of buffer there. Ioptron mounts, you can change the rate frequency, and the other legacy interfaces, there's nothing to update. So that is the other setup options you have in SkyTrack. Again, if you haven't set up your site yet, see the video called Basic Setup.